So we have the differential equation of second order, and this is non-homogeneous differential equation, and we need to find the solution of this differential equation, and we need to proceed in two ways. First of all, the first way is that we have to find the solution of the homogeneous differential equation if the right hand side is 0, and then afterwards we need to find the particular solution. This is homogeneous, and then we need to find the particular solution. And we denote the particular solution by yp. Okay, this is what we need to find, and here from this equation we have to find the homogeneous solution. Okay, the particular solution depends upon the right hand side, while the homogeneous solution depends upon the left hand side. So solution, what we do, we consider y is e raised to power lambda x be the solution of corresponding differential equation. So if this is the solution of this homogeneous differential equation, so it should satisfy this differential equation. So to satisfy this differential equation, we need to take the first derivative and the second derivative, and we need to plug in here in this differential equation. So for that reason, we need the first prime, that is actually lambda e raised to power lambda x, and at the same time we need the second derivative, that is actually lambda square e raised to power lambda x. So we plug in into 1, and we see what happens. This is going to be lambda square e raised to power lambda x minus 2 lambda e raised to power lambda x minus 3 e raised to power lambda x is 0. Now we can pull the e raised to power lambda x out, and we are left with lambda square minus 2 lambda minus 3 is 0. This implies that e lambda x can never be 0, which means lambda square minus 2 lambda minus 3 is 0. We need to find the values of lambda, and which is pretty simple, and we see if we apply the formula, or we can even factorize it. I mean, how this is going to be lambda square minus 3 lambda plus 1 lambda minus 3 is 0. We can break down this minus 2 lambda into minus 3 and 1 lambda, because the sum is minus 2, and if we multiply, this is going to be minus 3. So pull the lambda out from the first two terms. So this is lambda minus 3 plus 1 lambda minus 3 is 0, and from here we know that lambda is actually lambda minus 1 multiplied by lambda minus 3 is 0. And this implies that lambda is 1 or 3. So the fundamental solution of the differential equation 1 is y1. The first solution is e raised to a lambda x, and lambda we consider 1, so 1 x, and the second solution is e raised to power lambda x, and we consider the second lambda as 3x. So Now since the y1 and y2, these are two solutions of the given homogeneous differential equation, so the linear combination is going to be a solution as well. So it means y of x is the linear combination of y1 and y2, c1 y1 plus c2 y2 is also a solution of the homogeneous differential equation, and we know that the y1 is actually e raised to power x and y2 is e raised to power 3x. So this is the solution for the homogeneous differential equation. Now we need to find the particular solution, and the particular solution means like we have to find the solution of the right hand side. So what we do here, we consider that because here on the right hand side we have the exponential function e raised to power 4x, so we consider the solution, consider the particular solution is of type e raised to power a times a is any constant, a times e raised to power 4x. Why we consider this thing? Because on the right hand side, I mean, e raised to power 4x is appeared, so we have so this is a natural candidate to be a solution. We don't know what is a, we need to find a. So since we are considering that, okay, well, y is equal to a, e raised to power 4x is a solution of this differential equation, we plug in here and we see what happens. So we need the second derivative, first derivative, and y itself, and then we plug in into this one. So for this reason we need the first prime, and that is going to be 4a e raised to power 4 lambda, and we need the second prime, and that is going to be 16a e raised to power 4x. Now so we plug in y double prime here, y prime here, y here, and then equals to 2 e raised to power 4x. So we see what happens. So this is going to be double prime is 16a e raised to power 4x, and then we have minus 2 multiplied by 4a e raised to power 4x, and then we have minus 3y, and y is just a e raised to power 4x is equal to 16a e, I'm sorry, this is wrong, equals to 2 e raised to power 4x, which is the right hand side. Now simplify this to find a. So how can we simplify? This is just 16, and this is 4 to the 8. 8 and minus 8 and minus 3 is going to be minus 11, and 16, this is going to be 5a e raised to power 4x equals to 2e 4x, and this implies that if we compare the coefficients, so 5a equals to 2, 5a is 2, implies that a is 2 by 5. So it means the particular solution yp is, this is yp, I mean this is yp, and this is actually 2 by 5 e raised to power 4x. So the general solution of the given differential equation is actually y homogeneous plus y particular solution, and homogeneous is c1 e raised to power x plus c2 e raised to power 3x, and particular is actually 2 by 5 e raised to power 4x, and this is why. Thank you.